Alright, so in this video I would like to introduce yet another quantity that is related to electric potential. And to motivate this, I would like you to recall that the value of potential energy is arbitrary. And by that what I mean is we can add any constant value to potential energy and it won't change anything. So if I add, say, 1,000,000 joules to every energy measurement, it will not affect the physics at all. And the reason is because we only ever care about changes in energy. So even if I add some arbitrary constant to my energy, changes in energy will still be the same because the constant will cancel out. Okay, well, we defined a new quantity in terms of the energy. So because we have V is equal to U divided by Q test, the same thing has to be true for V. Okay, so in particular, the value of V is meaningless. All we care about is differences. Okay, so that difference, the change in electric potential from one spot to another, is called the electric potential difference. You might even want to use EPD as a shorthand for that, although delta V works just fine. Okay, so when I say we only care about the potential difference, what I mean is that that is the thing that is real. So delta V is a real quantity. It's something we can actually measure. And in order to do that, we use a device that's called a voltmeter. Okay, makes sense because it's measuring volts. If you were taking this class under normal circumstances, you would get to use these things and play around with them and hold them in your hand. But now you have to settle for me trying to draw one. And essentially what this looks like is it's just a rectangular device size you could hold in your hand. It's got a screen on it which lists some measurement in volts, so 0.0 volts per instance, and it has two wires connected to it. So one is the positive and one is the negative, which all that actually represents is that the positive one is the higher one. It doesn't actually mean one's positive and one's negative. One could be positive but less positive than the other. It's just saying which one's higher and lower. Okay, so these two wires we call leads. Anytime you have two wires connected to something, to a battery or a voltmeter or any other thing, we call them leads. And essentially what this does is the voltmeter tells you the delta V between the two leads. Okay, so it's measuring the electric potential difference. You always have to have two leads because it can only ever measure a difference. So if you just attach one wire to something, you'll always get a result of 0. You have to connect both things to get anything interesting. Okay, so an example of that is, let's say you take the voltmeter like this with its two leads and you attach them to a battery. Okay, here's my picture of a D battery. And let's say I attach one lead to this side and the other lead to this side. Okay, well what will happen then is the screen will display 1.5 volts of potential difference between those. In fact, if you look at any battery, it's always labeled with the electric potential difference between the two ends of the battery. So it will say 1.5 on the battery, and that's what the voltmeter will show, at least approximately. So over the lifetime of a battery, it will decrease gradually. Okay, in addition, let's say that I reversed the leads. Okay, so if I take the same voltmeter, so two leads like this, same battery, but this time I'm going to attach one to this side and the other one like this, so I've attached them oppositely. This time it will read negative 1.5 volts. Okay, so again, all the voltmeter measures is the difference. It's measuring whether the potential of one is higher or lower than the other and by how much. Okay, so because we only ever care about differences in potential and the actual value of potential doesn't matter at all, we are allowed to pick some random place that we want to call electric potential of 0. Okay, and we have a name for that. We call it the ground. So the ground is the arbitrary place we call V equals 0. All right. And the reason we call it that is because it is literally the earth outside your home is often defined to be V equals 0. If you build a new house, one of the things that you have to do before electricity is attached to your house is pound a long copper rod into the ground so that it makes good electrical contact with the physical dirt around your house. And then that ground rod is attached to the third hole in every electrical outlet in your house. So you may have wondered what that thing is for. It doesn't seem to do anything. Well, what it does is it keeps the appliances in your house at a stable ground. Otherwise, the two potentials in the other leads from the electrical outlets could drift and become higher or lower, and that could create a dangerous situation. So by keeping everything relative to the physical ground near your house, that is a safety feature. Okay, so another word that you will hear in reference to electric potential and electric potential difference is the word voltage. Okay, so I discourage you from using the word voltage in this class. I think you're better off just never using it. And the reason for that is because it is vague. So voltage is sometimes used to mean electric potential. But it sometimes means electric potential difference. And because we have two different quantities that are both measured in volts, the word voltage could mean either one of those, and it's not good practice to abuse terminology by using the same word to mean two different things. Okay, now the problem with what I just told you about avoiding using the word voltage is that practitioners only ever use voltage. So if you talk to an electrician, they will never ever say electric potential or electric potential difference. They will use the word voltage 100% of the time. And so this is really kind of a historical split between scientists and practitioners. Electricity is a little unique in this regard that both everyday practitioners, people playing around with electricity in their garages in the 1800s, and scientists who were studying things with careful equipment and labs, were both equally instrumental in developing the theories of electricity. And so they simultaneously came up with separate terminology as they went. And so both are equally used. Scientists will talk about electric potentials, electric potential differences. Practitioners will talk about voltages. And again, I think that's fine once you leave this class if you have an appreciation that electric potential and electric potential differences are not the same thing. You can usually tell from context whether someone is talking about a voltage as a V or a voltage as a delta V. But for now, I have no reason to think that you have a deep understanding of that difference, so I highly encourage you to always use electric potential and electric potential difference. Another detail about using voltage is it just kind of sounds weird. So, to a scientist's ears, describing a quantity by the units that you use to measure it doesn't make a lot of sense. So, for instance, if you buy a house, you might see on a listing the acreage. And so an acre is a unit of area. And so I would describe that as the area measured in acres. But acreage is often used by ordinary people to describe that. Another example is if you go buy a light bulb, you might look up what is the wattage. But watts are just a unit of power. So I would ask, what is the power of this light bulb? And then answer, it's 100 watts. I wouldn't ask what is the wattage. I just think that sounds funny. And the reason I think that sounds funny is because if you measured the length of something, you wouldn't describe that as the meterage. Even though it's measured in meters, that sounds really weird. You would say, what's the length? And then you'd say, oh, it's 2 meters long. Or similarly, you wouldn't say, what is the literage of this, container? You would ask, what is the volume? And again, that's because it sounds weird. So instead of saying, just because we measure it in liters, I'm going to call it literage, no, it's still a volume. And so I would say, what is this volume? And we measure it in liters. Okay, so I think the same sort of thing applies to volts. Just because we measure a quantity in volts doesn't mean that we should call it a voltage. In fact, there are some even different quantities that we'll study later on that are also measured in volts, and I think it would be wrong to describe those as a voltage because they're really pretty different from this thing that we're measuring in volts now.